All right, boys and girls, welcome back to the drive-through as we make our way through Chapter 4, the last lesson before your Chapter 4 assessment. And this is a really good little back and forth here. It's called Taking Sides, and it basically is giving you a chance to decide who is right in each of these scenarios. So if you're doing this right, you shouldn't be just watching the video to get the answers, but you should be reading through these questions and then make a decision on who you think is correct before you watch the video, and then pause it and then take notes accordingly and see how you do. Okay? This is I think what's wrong about the world we live in maybe is that we focus more on who is right and not what is right, but in this particular scenario, it's math. So that's the nice thing about math, is there actually is a right and a wrong. So hopefully you've read through the example. Notice that Serena was right. 6 less than a number is n minus 6. It's not 6 minus n. And they do a good job of explaining why that is the correct answer above. So we're going to move on into number 1. Okay. The graph is x is greater than or equal to -7. And this is talking about a graph on a number line. So we got a number line. And the question becomes, do we put an open dot at -7 or a closed dot? So let's take a good read at it. So we put a couple numbers on the number line there. Now, it always helps to read this out loud. X is greater than or equal to -7. It's telling us what x is allowed to be. So is x allowed to be -6? Sure it is. -6 is bigger than -7. Is x allowed to be 0? Sure. X is allowed to be 0. So what I want you to understand when you're doing questions like this is you cannot write the answers to this question because there are infinitely many answers. So then we have to use a graph to demonstrate the answers. So the question becomes, is -7 greater than or equal to -7? Well, yes, it is. So that answer works, and that's why we color it in. Every other answer to the right of that will also work, which is also why we color all of those in. And so we're telling our audience that all of these shaded answers are correct. So Serena is right again. Number 2. They're looking at the problem 3x plus 1 is greater than 0. Serena says that the inequality is always true because multiplying a number by 3 and adding 1 to it makes the number greater than 0. Is she right? No. No, no, no. Serena forgot that we can multiply by negative numbers. Let's put in -100 for x. You get -300 plus 1, which is -299, and that is certainly not greater than 0 or positive. So Serena is wrong because putting in some negative numbers will cause it to be incorrect. It's not really asking for me to solve for it, so I'm not going to. Number 3. 4 greater than x. 4 greater than x. Joaquin says that they should write 4 is greater than x. See, this is a sentence, and this is an action. 4 is greater than x. Serena says they should write 4 plus x. 4 more than x. And I believe in this context, they are referring to 4 more than x. So Serena is yet again correct. Joaquin is writing down 4 is greater than x. So that's my explanation. All right, Joaquin is thinking hard about the equations and inequalities. So if 45 plus 47 equals t, then t equals 45 plus 47. So what he's saying is that we can rewrite the order of this. So if 45 plus 47 is less than t, then t is less than 45 plus 47. Well, let's just take out the 45 plus 47 and make it way more simple for us to understand. This is what math teachers do sometimes, is they just see if you can fight through the confusing part. One thing that confuses me is 45 plus 47. I'd rather just look at that as 92. So they're saying if 92 equals t, then t equals 92. I think that is correct. What that's saying is if we have equalities, we can flip the left and the right side without changing the sentence. I am Greg, Greg is I. Same sentence. Okay? However, if you say, we wouldn't really say 92 is less than t, right? You would say t is greater than 92. And over here, t is less than 92. And hopefully you understand that you cannot be greater than something and be less than something. So this is not true. No, not right. And the reason why is that you can switch the order of a statement if it's based on equality, but you cannot switch the order of a statement if it's based on inequality. In fact, you'd have to switch the inequality sign. Okay, number 5. Scrolling down here, give myself a little more room. Joaquin's question in number 4 made Serena think about other similarities and differences between equations and inequalities. Serena wonders about the equation negative x over 3 equals 4, and the inequality negative x over 3 is greater than 4. Explain to Serena ways that solving these two problems are alike and ways that they are different. How are the solutions alike and different? Let's just do a little case study. So negative x over 3 equals 4. We'll do that in blue. And then sometimes green's hard to see, so I'm going to switch over to pink. Negative x over 3 is greater than 4. Okay, let's multiply both sides by 3. Then you get negative x equals 12. Well, there's a 1 there. So just divide each side by negative 1. And you get x equals negative 12. Let's make sure we did that right. Negative 12 divided by 3 is negative 4. The opposite of negative 4 is positive 4. So that is correct. Now let's solve this one. Multiply both sides by 3. You get, again, negative x is greater than 12. Divide each side by negative 1 in this one, and if you remember from the last video, hopefully, we have to switch the sign when we multiply or divide by a negative. So what's different about inequalities is that when we divide or multiply by a negative, we have to flip the sign. And I always like to remind students why that is. There was no person that made the 10 commandments of algebra and made these rules. It's just how the numbers work. Look at negative 2 and negative 10. Which one's bigger? Negative 2 is bigger. I'd rather owe someone $2 than owe them $10. Now let's divide each side by negative 2. Divide each side by a negative. Well, what happens when we divide by a negative? You get a 1 here. You get a 5 here. Which one of these numbers is bigger? The 5 is bigger. So that is why that is a rule. No one made these rules. They're not man-made. They're just the way that the math works, which is a really nice thing. Okay? Not a big fan of rules otherwise. So what's the other difference? Well, x equals 12. How many solutions are there to that? There's one. The only thing x can be to make this blue equation true is negative 12. It is the only solution to the problem. Whereas in x is less than 12, there are infinitely many answers to that question. And so the only way to write all of the answers down is with a list, an inequality, or a graph. Notice I'll put an open circle there because 12 is not less than 12. And I don't want my audience to think that it is, but then I'll color everything to the left, and all of those answers will work. All right, number 6. Joaquin, he needs to get his act together. He solved that by adding 15 to each side. Serena said he was wrong because he is. How do you get rid of multiplication? You would divide each side. So, once again, Serena is right. Okay? So, when Joaquin checked his work, he put 150 in for the Q in the original inequality. Well, that worked, but that doesn't mean that he was correct. It does not prove that he is correct. You'll learn in geometry it is a lot more difficult to prove that something is correct than it is to prove that something is incorrect. All you need to do to prove that something is incorrect is one counterexample. Whereas to prove something is correct takes a lot more work, and you'll get to that as you get older in math, okay? So, look, Q is less than 150. And they're saying, let's find a number that satisfies this, but doesn't work. Well, let's let Q, Sonic. Let's let Q equal negative 100. I picked that one because it's easy to do in our head. What is negative 15? What is negative 15 times negative 100? Well, that is positive 1500. And which one of those is bigger? Certainly this one. So that disproves, or it proves that Joaquin is incorrect, or it disproves Joaquin. That is called the counterexample, or a counterexample. Okay? Serena's checking her work. We're on to number 7 now with Joaquin, and finds that they disagree on a problem. What a surprise. Here's what Serena wrote. So this was the problem she wrote down. How did she get from step 1 to step 2? It looks like she subtracted 3 from both sides. We're allowed to subtract 3 from both sides, and it looks like she did that accurately. Okay? It then looks like she added 2x to both sides. No, she should have added 2x to both sides. She subtracted 2x from both sides. So this is the wrong step. That is incorrect. So let's go back to 3x is less than or equal to negative 2x plus 2. What are we solving for? X. What do we need to do? We want to move the negative 2x over to this side so we just have a number over there. Well, how do we move the negative 2x? It's being added to the 2, okay? But they're adding a negative. So how we get rid of adding a negative is we're just going to add 2x. The best way I can explain it to you is, what is negative 2x plus 2x? That is 0. That's what we wanted. And 0 plus 2 just gives us a 2. So we got to add 2x to this side. So you get 5x is less than 2. Divide each side by 5. And you get x has to be less than or equal to 2/5. Okay, Serena was incorrect. 3 more. Alright, so now we're solving negative 4 times 3m minus 1 is greater than 2 times n plus 3. How should she solve the inequality? Show all the necessary steps and identify the properties. First thing I'm going to use is the distributive property. I'm going to distribute the negative 4 on the left side and the 2 on the right side. So I have negative 4 times 3m. Well, I don't need to do that. Let me just write it out. You guys are good enough to do that. Sorry. No. Okay, so it's negative 12m. Negative times a negative is a positive, so plus 4 is greater than or equal to 2m plus 6. Okay. I prefer to not have to multiply or divide by a negative if I can, so I'm actually going to add 12m to both sides, and that's the addition property of equality. So that gives you 4 on the right side, and all that says is I'm allowed to add the same thing to both sides. Now I'm going to subtract 6. When you get negative 2 is greater than or equal to 14m. Okay, so that was the subtraction property. Now I'm going to use the division property to divide both sides by 14. And I get m has to be less than or equal to negative 1/7. That's just simplified. Okay, I think that's right. Let me double check that works since it's an odd answer. Let's see, I distributed. Did I distribute correctly? Negative times a positive is a negative. That's a positive 2m plus 6. Then I added 12m. That looks like the right thing to do. Then I subtracted 6 and I got a negative. I think that is correct. Okay, number 9. Joaquin and Serena know that some equations are true for any variable of the variable, and some equations are never true. Oh, these are good ones. They're wondering about inequalities. What could you tell them about the following inequalities? Do they have solutions? What are they? How would you graph their solutions? Okay, is 4x plus 6 greater than or equal to 6 plus 4s? Well, let's see. How do I want to show you how to do this? Let's subtract 6 from both sides. You get 4s is greater than or equal to 4s. And let's, I guess, divide each side by 4s, and you get 1 is greater than or equal to 1. Okay, do they have solutions? Well, 1 is equal to 1, and 4s plus 6 is equal to 4s plus 6. It's not greater than or equal to, but it is equal to. So I think this is true for all solutions, weirdly enough. I don't love this part of math, so don't worry about this too much. All solutions are true. No matter what we put in for s, it's going to be greater than or equal to the other side. It's going to be equal to it. Let's see. Now this one we can just solve for maybe. So let's see. Let's subtract 5 from both sides. And you get 3r is greater than 3r. I need more space. Minus 7. Move over here for this one. 3r is greater than 3r minus 7. I'm just going to rewrite that. Okay. Let's subtract 3r from both sides. We are allowed to do that. 3r minus 3r is 0. Is 0 greater than negative 7? Yes. So no matter what value we put in for r, this will always work. So once again, all these solutions are true. Okay? Now let's look at letter C. I'll do this in a different color. You get 4n plus 4 is less than 4n minus 3. Well, let's subtract 4n from both sides. You get zeros for both of those. You get 4 is less than negative 3. Well, that's never true. Never, ever. And that means no matter what value you pick for n there, you're never going to get something that's true. So this is never true, or no values for n are true. Okay, so now they get ax plus b is greater than c to solve for x. Joaquin said he's going to solve it like an equation. Serena says she needs to be careful because if a is negative, the solution will be different. I agree. I agree. So, if you start with ax plus b is greater than c, and you don't know any other information about these then you can subtract b from both sides. That doesn't affect anything. So you can say that ax is greater than c minus b. But when you divide by a here, you get x is greater than c minus b over a if a is bigger than 0, if a is positive. But if a is negative, x will be less than c minus b over a if a is negative. And you get x doesn't even exist if a equals 0, because you're not allowed to divide by 0. Go ahead and divide something by 0 in your calculator. It gives you an error message, because you can take a pizza and divide it up into one piece. You can even divide it up into half pieces. That'll double your pizza, but you cannot divide anything up into 0 pieces. And that's the end. Boom!